the Membrane Facility 101. My name is Miranda, and today I will be your guide and showing you all you need to know about the membrane transport. So, what is a cell membrane? There are individual cells, which are surrounded by lipid layers. The cell membrane is what holds different components together and protects it from the environment outside the cell. They regulate what enters and exits the cell, and try to avoid the loss of nutrients and extraction from too many ions. The cell membrane is made out of three different things. First, there are the phospholipids. Imagine you cut open a lasagna. What do you see? Layers of the same ingredients. This is how the phospholipids are arranged. They are divided into heads and tails. The heads are hydrophilic, which are attracted to water, while the tails are hydrophobic. They don't really like it. The head is made out of phosphate molecules, while the tails are made out of fatty acids, a chain of carbon atoms. Like, please. So, the second thing is the cholesterol. They regulate the molecules that enter and exit the cell. And FYI, they are made out of a type of steroid, which is what I use. Okay. Lastly, there are the proteins. They are divided into two things, like the integral and the peripheral. So, the integral are in charge of transporting large molecules, like glucose, while the peripheral helps with the transportation and the communication. The integral proteins are divided into two things, the polar and the non-polar molecules. This is where my friends come in, the electrons. Okay, so the non-polar have an equal distribution of electrons. They have the same amount of positive charge and negative charge, while the polar are not equally distributed and have a more positive charge than negative charge of electrons. Oh my god, my favorite part! Okay, so there are the passive transport and the active transport, like get to my level. Okay, so to explain this, imagine two mountains with a valley in between. These are the only transports that a molecule can go through. In the passive, you're on a sledge, riding down this snowy hill. And you do not require energy because you're going downhill with no effort. On the active, you're pushing the sledge upwards, and you're going against their gradients, and therefore you require energy. The transporting channels are made out of proteins.
Ion channels permit passive transport of ions. Ion channels can be classified by how they change and their open and closing state responds to different factors of the environment. Common types of ion channels include leak channels, almost open, allowing a steady flow of ions. Ligand-gated channels, open upon the binding of the ligand, and voltage-gated channels that are regulated by the membrane voltage. They open at some values of the membrane potential and close at others. Leak channels are almost open, allowing a steady flow of ions. Ligand-gated channels open upon the binding of the ligand. And voltage-gated channels are regulated by the membrane voltage. They open at some values of the membrane potential and close at others. Woohoo!
Imagine the cells are all ready through the channels. When the cells communicate, there is one sending cell which sends the receptor to the receiving cell. That is how they communicate. But not all cells receive the message, since they can select which cell is receiving the receptor.
And that's it for today, kids. I am trying my best. Remember, don't do drugs.